At Test Prep. Today's day 49 in our 90-day SAT Prep series. Today we're going to be spending about half an hour with the Math No Calculator section, and then anywhere from 20 to 30 minutes with the SAT Reading section. So for today's Math No Calculator section, yesterday, if you're following our program, you should have taken SAT Practice Test 4, the Math No Calculator section on your own, and tried to use the pacing tips that I provided from days 44 to 47. So hopefully you were able to use those pacing tips. Hopefully they were helpful. As far as what we're going to be doing today, I'll be now taking that same practice test that you did yesterday, so that way you can compare how you did. First, that way you can check your answers. If you haven't yet, you'll be able to check them in this video. But also you'll be able to see how your pacing compared to mine. You'll be able to see the things that I use on different questions to save time. So even if you got a question correct, pay attention to how I'm doing it, because I still might be doing it in a more efficient way that takes less steps and takes less time. So if you got a lot of your questions right, but you only had about 2 minutes to check your work at the end, or you had less than 8 minutes to check your work, then just pay attention to how I'm saving time, little things that I do in order to find the answer faster. Pay attention to those things. But yeah, so basically I'll be taking SAT Practice Test 4, the Math No Calculator section, as basically a walkthrough showing you how I would take it if I were taking the Math No Calculator section. So pay attention to the certain strategies that I use, pay attention to my pacing, and with that, we're going to get started here once my timer hits a minute 45. So your timer will probably say a minute 40, mine will say a minute 45, but we're going to get started in about 5 seconds here. Okay, so we got 5, 4, 3, 2, 1. All right, let's get started. So which of the following expressions is equal to 0 for some value of x? Okay, I see I've got absolute value here in b through d. I know that the minimum of absolute value is at 0. Okay, that's its minimum. I see it's got plus 1 all right here, which means that it can never equal 0 because it always at minimum will be 1. So all of those are wrong. A is my correct answer there. Okay, option 2, or question 2. In the function above, b is a constant. If f of 6 is 7, what's f of negative 2? Okay, f of 6 means I'm plugging in 6 for x. 3 over 2 times 6 is going to give me 9. So now I have 9 plus b equals that 7 from right here. I go ahead and I subtract 9 from each side to solve for b. 7 minus 9 gives me negative 2 equals b. So b is negative 2. I'm asked for f of negative 2. Okay, so b is incorrect. Keep in mind that that's a answer designed to distract you. So negative 2 is what I'm asked for here, f of negative 2. So I'm going to plug in negative 2 then for x. Okay, so I got 3 over 2 times negative 2. I see that what's going to cancel there is my 2, so I'll have negative 3 then, and then I have plus b. I know b is minus 2, so then I know that's going to give me negative 5. Answer is going to be A. Okay, number 3. If xy is a solution to the system of equations above, what's the value of y? All right, well, I'm given what x is, so I'm just going to substitute that in up here. Okay, so now I'm going to have, that's going to distribute here, so I'll have 4 times y is 4y, 4 times 1 is plus 4, so I'll have 4y plus 4 all over y equals 6. I multiply each side by y. Now I got 6y there. I'm going to minus 4y from each side, so minus 4y from each side to isolate y. Now I get 2y equals 4, divide each side by 2. That's going to give me 4 over 2, which is equal to 2. So y is going to be 2, so my answer for 3 is going to be A. Okay, now I've got question 4. Question 4. If f of x is equal to negative 2x plus 5, what is f of negative 3x equal to? That means I'm plugging in negative 3x for x. What's negative 2 times negative 3x? That's positive 6x, and I still have plus 5, so my answer is going to be B. Okay, now I got question 5. Question 5. Okay, which of the following expressions is equivalent to the expression above? Okay, what I'm going to do here is I'm going to do this 2x times 4x. That gives me 8x squared. Keep in mind I still have to multiply my 3 there. When I do that, I see that I'm going to get 24x squared, so A is wrong and D is wrong. Okay, next thing I see is I got to solve for my x term since my constants are the same. Solving for my x term, I see I'm going to have a plus 4x, and then I'm also going to have a plus 2x. So plus 2x. So in total, that gives me plus 6x times this 3 right here, which will give me plus 18x. So my answer there is going to be C. All right, number 6. If A minus B over B is equal to 3 over 7, what must be true? Okay, I can go ahead and say that B is going to equal 7 then, since I see that it does there. So B is 7. Okay, so I'll put a 7 in here. I'll put a 7 in here. Now I can go ahead and solve for A. I'm going to multiply each side by 7. Okay, multiply each side by 7. That's going to cancel there. Now I've got 3 equals A minus 7. I'll add 7 to each side. 3 plus 7 gives me 10 equals A. So 10 is equal to A. So A is 10. Okay, next thing I'm going to look at. I see I've got A over B in these two. I know A over B, A is 10. I know B is 7, so that should be 10 over 7, which it is in B. So B is my correct answer for 6. Okay, I go up. Now I got number 7. While preparing to run a marathon, Amelia created a training schedule in which the distance of her longest run every week increases by a constant amount. If her training schedule requires her longest run in week 4 is 8 miles and the longest at week 16 is 26, what best describes how the distance changes between week 4 and 16? Well, if I'm going from 8 to 26, that's an increase of 18. So I rose by 18, and I ran by my change in number of weeks, which is 16 minus 4, which is 12. I see if I simplify that, that's going to give me 3 over 2, or 1.5. Okay, so I look for an answer choice where it says Amelia increases the distance of her run by 1.5 miles each week. So I see then my answer, that's number 7, is going to have to be D. Okay, now I go on. Moving down, now I've got question 8. Which of the following equations represents a line that's parallel to this one? Okay, if it's going to be parallel, I see I've got a slope of negative 3x, so I need to have another slope with negative 3x. Okay, so I look here, I got to just go through options A through D. That's the only way here. If I was to subtract 6x from each side, negative 6x, then split it over 2y, okay, I see that I end then with negative 3x. Okay, so that's going to have the same slope for A. Now I've got question 9. If A is equal to 2, what's the solution set of the equation above? I'll plug a 2 in here. Next thing I'm going to have to do is I'm going to have to go ahead and square each side. Okay, I'll square each side. When I do that, I'm going to get x minus 4 squared. That's going to be x squared minus 8x plus 16. Okay, I got that by doing x minus 4 times x minus 4. So I got that. That's going to be set equal then to x minus 2. At that point, what I do is I go ahead and set it equal to 0. So I'll add 2 to each side. 16 plus 2 gives me 18. Next, I got to subtract x from each side. Negative 8x minus x gives me negative 9x. Now I got x squared minus 9x plus 18 equals 0. Now I factor this out. I can take an x there, multiply it by an x there to get x squared. Now I'm looking for factors of 18 that add to negative 9. I know that that's going to be negative 6 and negative 3. At this point, I know my options for possible solutions are x equals 6 and x equals 3, but I have to check them. Okay, so I'm going to go ahead and check. We'll check 3. If we're going to plug 3 in here, let's go ahead and do that. Plug 3 in for x. Okay, so we'd have 3 minus, we know a is 2. That's 3 minus 2, that's 1. The square root of 1 is 1. Does that equal 3 minus 4? Well, 3 minus 4 is negative 1, so that does not equal. Okay, so 3 can't be a solution, so I can get rid of a. B isn't a possible solution. Like I just said, 3 doesn't work, so my answer there is going to have to be D for number 9. All right, now we've got question 15 through 18, right? Because I went 1 through 9 as I suggested in my pacing video. Then I go 16 through 18. So that's what I suggested in my pacing video. That's what I'm doing here. Okay, I see that I've got an 18-inch height here. I'm asked, Jim has a triangular shelf system, attaches to a shower head. Total height's 18 inches. There are 3 parallel shelves shown above. What's the maximum height in inches the shampoo bottle can stand upright on the middle shelf? Well, that's going to be here to here. Okay, from there to there. If I look at that, I see that I've got similar triangles right here, and then I've got another similar triangle there. Okay, so what I know then is that this 18 inches going vertically, if I have 3x here, that's my middle part. If I take that middle part and I set it over my total, which is that 3x over that 3x plus this 2x plus this x, which is 6x, I see that that gives me a half. If I take that half then and I multiply it by this 18, so this 18 by 1/2, that's going to give me 18 over 2, which I know is equal to 9. So I know that my maximum height is going to be 9. So the answer there is 9. Okay, that's using similar triangles. All right, so that was question 16. Now we got question 17. A triangle above, it's got the sine of x is 0.6. What's the cosine of y? That's also 0.6. Okay, we know that because we know that the cosine of y is the complementary angle to angle x. Okay, so the sine of whatever x is then is going to have to be the cosine of y. So that's also 0.6. Okay, number 18, I've got an equation here for what real value of x is the equation above true. Here I'm going to have to do grouping, I see, so I'm going to have to take this 2. I'll do 2 times x minus 5 because that's going to give me 2x minus 10, so I'm going to group that. Next thing I'm going to have for a group is right here because I can factor out an x squared, so that would give me x squared times x minus 5. All right, so now at this point, with that grouping, keep in mind that this is plus there. So with this grouping, what I do then is I take that x minus 5, I see I can keep that together, and then I'll have that x squared plus 2 as the other factor. So at that point then, what I'm going to do is I'm going to, obviously that's set equal to 0 since I have a 0 there, so I'm going to set that equal to 0. Then at this point, what I do is I look for a real solution because it has to be real. The easiest real solution I see is going to be that x equals 5. Okay, this will be imaginary because it would end up being x squared equals negative 2, so it's going to be imaginary. So the real solution will be x equals 5, which means our answer then is going to be 5. Okay, at this point I glance at 19, 20 like I talked about in my pacing video, see if they're easy. If they are, I solve them. I see 19 looks easy. I see 20 looks fairly easy. Though it is long, it does look decently easy. It's not anything that looks too difficult. Okay, so now I've got if xy is the solution to the system of equations above, what's the value of x? Okay, well, I see a stacked equation, so I'm just going to look to get rid of y by adding or subtracting. So the first thing I'm going to do, I see I got 4y, I see I got 3y. The lowest common denominator in that, or the least, like the lowest multiple, is going to be 12. So if I'm trying to get it to 12, multiply my top one by 3, multiply my bottom one by 4, then I'm going to have to subtract them to get rid of my y's, since they're both going to be positive. So keep in mind that that's 4, and I'm going to have to subtract it. Okay, so I go ahead and distribute my 3 to all these numbers, distribute my 4 to all these numbers. Okay, so I'm going to have 12y minus 12y, y is going to cancel. I'll have 3 times negative 3x, that leaves me with negative 9x. Then I'm going to have that minus 4 times 6x, which is going to be minus 24x. Okay, that's going to give me negative 33x. As far as my constants, I'm going to have a 3 times a 20, which is a 60. And then I'll have 60 minus 4 times 15, which is also 60, so that's going to equal 0, which means x then is going to equal 0, so my answer for 19 is 0. Okay, 20. The mesosphere is the layer of Earth's atmosphere between 50 kilometers and 85 kilometers above Earth's surface. It's at a distance of 50 kilometers above Earth's surface, the temperature is -5. At a distance of 80 kilometers from Earth's surface, the temperature is -80. For every additional 10 kilometers, I got to pay attention to that, from Earth's surface, the temperature in the mesosphere decreases by k degrees Celsius, where k is a constant. What's the value of k? All right, well, I see my change is going to be that -75 drop in degrees over the 30 kilometers that we change in our distance. Okay, so over that 30 kilometers. So I'll put this as Celsius degrees. Okay, so if I was to go ahead and do this, I would see that I'm going to end up with a change of, it looks like -2.5, right, per degree Celsius. But I got to keep in mind then that that's every 10 kilometers is what I have to answer with, or 2.5 degrees Celsius per kilometer. I got to multiply that by 10 kilometers because I'm asked for every additional 10 kilometers. Okay, when I do that, kilometers cancel. I see I end with 25 degrees, which I just plot as 25 because I don't have to include the degrees. Also, don't have to include the negative because it says decreases. So 25 is my answer there. So 25 is answer for 20. At this point, I go back and answer 10 through 15, just like I talked about in my pacing video where I talked strategy behind it. Okay, so I've got an equation up here. I'm asked what the value of t is, so I just go ahead and solve. Got to multiply each side by t minus 5 then. Multiply each side by t minus 5, 10. I distribute my 10 here and here. That's going to give me 10t minus 50. That's going to be equal to t plus 5. At this point, get all my t's on one side. I'll go ahead and I can pick either way. I'll keep t positive, right? I always want to keep my coefficient in front of my t, or my variable I'm trying to solve for, positive. So now we got 9t. That's going to equal, I add 50 to each side. 50 plus 5 is 55. Divide each side by 9 to isolate t. I get 55 over 9, which is answer choice D. Okay, now I've got 11. How many ordered pairs satisfy the equation above? All right, so I've got an x equals that. I'm going to plug in this y here for x, set it equal to 0, then use the discriminant to solve for how many ordered pairs I have that satisfy the system. Okay, so I'll show you that. So I'm going to have this y is going to get plugged in with that 2, so I'm just going to go ahead and do this. 2x times x is going to give me 2x squared. I'm going to have minus 3x, and then I'm going to have plus 9 times 2x, so that's plus 18x minus 3x, which gives me plus 15x. Then I'm going to have minus 3 times 9, that's minus 27. Okay, now I got to keep in mind I got to multiply that by 2. So multiplying that by 2, and then I'm adding 5 to it. Okay, and I'm also keeping in mind I got to subtract my x that was over here because I have an x here. I'm going to have to subtract that x. Okay, so when I do that, I'll go ahead and multiply this 2. Okay, keep in mind I still have to subtract that x wherever it is. Okay, multiplying by 2, that's going to leave me with 4x squared. Then I'm going to have 2 times 15x, that's 30x minus x, that's going to be plus 29x. Okay, then I'm going to have 2 times negative 27, that's going to be negative 54. Negative 54, I add 5, that's going to give me negative 49. Okay, so that's all set equal to 0 at this point. At this point, I use what's called the b squared minus 4ac. Okay, if that's positive, right, it's greater than 0, then that means that I have 2 real solutions. So let's take a look and see what that equals. So I got b squared. B is going to be this 29x. So 29 squared is obviously going to be very large. Then I'm going to have to minus 4 times a, which is I see 4, and then multiply that by c, which I see is negative 49. Okay, these negatives here that I'm connecting with these arrows, that'll make it a positive, so it's definitely going to be greater than 0, which means that I'm going to have 2 real solutions since it's greater than 0. So answer there is going to have to be C for number, that is 11. Okay, so we got C for 11. Now we've got question 12. Give me one moment here. We've got question 12. All right, let's get into question 12. Okay, so we've got Ken and Paul each ordered a sandwich at a restaurant. The price of Ken's sandwich was X dollars. The price of Paul's sandwich was $1 more than the price of Ken's. So Paul's equal to 1 plus X. K is equal to X. Okay, if Ken and Paul split the cost of the sandwiches evenly and each paid a 20% tip, which of the following expressions represents the amount each of them paid? Okay, well, we know that we have X plus 1 plus X based on this word problem here. So that's going to give us 2X plus 1. Okay, keep in mind we got to pay a 20% tip, so that's going to be 1.2 times that. And then we also are splitting it among two people. So we go ahead and do this. We're going to get 2.4x plus 1.2, 2.4x plus 1.2 all over 2, which will leave us with 1.2x plus 0.6. So our answer there is going to be C for number 12. Okay, now we got question 13. All right, so I'm told f and g are defined by this and this. They're graphed in the xy plane. Graphs of f and g intersect at points k0 and negative k0. What's the value of k? All right, well, I can go ahead and use the fact that y is going to be 0, or that f of x will be 0, so I'll plug 0 in there. I'll add 2 to each side to get rid of that. So now I've got 2 equals 8x squared. 2 equals 8x squared. Divide each side by 8. 2 over 8, that's equal to 1/4. So I have 1/4 equals x squared. 1/4 equals x squared. Take the square root of each side. Square root of 1/4 is going to give me 1/2. So my answer there is going to be 1/2, which is B. So B is my answer there for 13. Okay, at this point we got question 14. It's up here. Okay, I'm asked to solve for the value of A by rewriting this expression. So we rewrite it in the form A plus BI, solve for the value of A. So I just got to solve for my constants. I know that I got to multiply by my 3 plus 2i over 3 plus 2i. Okay, when I do that, I see that in my denominator, I'm going to have a 9, and then I'll have a negative 2i times 2i, which is negative 4i squared, which means it's going to be plus 4 since I squared is negative 1. I see that then my denominator is going to have 13. Up top, I'm going to have 8 times 3, which is 24, and then I'm going to have a minus I times 2i, which will give me minus 2i squared, which becomes plus 2. So then it's going to be 24 plus 2, which is going to give me 26 over 36, which is 2. So answer for 14 is A. Okay, now we got question 15. Question 15, in the quadratic equation above, k and p are constants. What are the solutions for x? Okay, I got to multiply this whole thing by 2. Or I guess I'll wait. I'll first show you that I got to set it equal to 0. So I got to set it equal to 0 to use the quadratic formula. So I got to subtract 2p from each side. Okay, so I can go ahead and rewrite that. Minus k over 2x minus 2p equals 0. Okay, when I do that, I see I have to multiply by 2 to get rid of that fraction. So multiply my whole equation by 2. That's going to be 2x squared minus kx minus 4p equals 0. At this point, I go ahead and use my quadratic formula. So I'm going to do negative b plus or minus root b squared minus 4ac all over 2a. All over 2a. I see my denominator. 2 times a, I see a is 2, so it's all going to be over 4. I know negative b. I know that b is negative k, so negative k is going to leave me with k. So I'll have k over 4, so I can go ahead and get rid of c and d. Then I'm going to have plus or minus the square root k squared, and that's going to be minus 4 times a. That's going to be minus 4 times 2, since a is 2, and then times c, which is also negative 4. Okay, I see that that's going to give me plus 32, so my answer there is going to have to be B. Okay, at this point, we've gone ahead, we've answered all of our questions, 1 through 15, or 1 through 20, we've answered all of them. We see that we have about 8 minutes left, which is ideal. Like I said before, we want ideally 10 to 8 minutes left to check our work and match everything to our bubble sheet. So at this point, like I said in my pacing video, I would go back and I would just check things with my bubble sheet. So I'd make sure everything that I wrote down in my test booklet, all the answers that I circled, are the same as what I put down in my answer sheet. So let's go ahead and do that. So I'm going to allocate that time here, even though I'm not actually filling out a bubble sheet, just so you get an idea for the pacing. Okay, so question 1, A. Question 2, A. Question 3, A. Question 4, B. Question 5, C. Question 6, B. Question 7, D. Question 8, A. Question 9, D. Question 10, D. Question 11, C. Question 12, C. Question 13, B. Question 14, A. Question 15, B. Question 16, 9, question 17, 0.6, question 18, 5, question 19, I see 0, and then 20 is 25. Okay, so at that point I've gone through, I've made sure that everything in my answer sheet matches what's in my test booklet. Now I go through and I check my work and all my problems. I'll put it in green so you can see it's me checking my work. Okay, I'm asked which of the following is equal to 0 for some value of x. Okay, I see all A through C are absolute value, which means it's minimum 0. They all have plus 1, so minimum is going to be 1, so answer's got to be A. That's checked. Number 2. Go down here. I'll erase this so I can see it better. I'm told f of 6 equals 7. Plug a 6 in here. 3 over 2 times 6 is going to give me a 9. 9 plus b's got to equal 7, so it's going to have to be minus 2 is what b is going to be. B will be minus 2. I'm asked for the value of f of negative 2. Negative 2 times 3 over 2 gives me negative 3. Negative 3 minus 2 is negative 5. That one's checked. Okay, now I've got number 3. If there's a solution, what's the value of y? Okay, I go ahead and plug in what this x says up top for this x right here. That's going to give me 4y plus 4 over y. Multiply each side by y. It's going to give me 6y. Subtract 4y from each side. As I do right here, that's going to leave me with 2y equals 4. Divide each side by 2. Answer's going to be 2. That's correct. Number 4, I've got f of x is equal to negative 2 x plus 5. What's f of negative 3x? That's going to be negative 3x times negative 2. It's plus 6x plus 5. Answer there is correct as well. Number 5, I've got which of the following expressions is equivalent to the expression above. I distribute this 2 over to that 4x. That's going to give me positive 8x squared. Multiply it by 3. That's 24x squared. So now between these two, now I got to solve for my x value. That's going to be plus 4x and then plus 2x on top of that. That's plus 6x times 3 plus 18x. That's correct as well. Number 6, I'll erase some of this. Which of the following must also be true? I see b is going to have to be 7 since that's what's in my denominator. So 7 there, 7 there. Multiply each side by 7. That's going to give me 3. 3 is equal to a minus 7. Add 7 to each side. That's going to give me 10 is a, which means a over b is going to be 10 over 7. That's correct as well. Number 7. Got a word problem. I see week 4, her distance is 8 miles. Week 16, it's 26. That's an increase of 18 over 12 weeks, which is an increase of 3 over 2, which are 1.5. So that one's also checked. D is correct there. 8, which of the following is equivalent or represents a line that's parallel to this one. If it's parallel, it's got to have the same slope. I see an A. I'm going to have negative 6x over 2. That's going to give me negative 3x, which is the same slope. That's correct. Number 9. Got an equation here. What's the solution set? Okay, I can just plug in and check my answer for this one. So I answered with 6. So I'll plug in 6 and I'll just check 3 as well. Or I guess I should just check my whole thing. So we'll go ahead and do that. So we'll have x minus 4 here. I square each side. That's going to give me x squared minus 8x plus 16, which I got there. I go ahead and set it equal to 0. Now I got x squared minus 9x plus 18 factored out. See, these are going to be my factors. That's correct as well. Those are correct. I check 3 again. 3 minus 2 gives me root 1, which is 1. 3 minus 4 is negative 1. 3 can't be correct. 6 minus 2 gives me root 4, which is 2. And then 6 minus 4 is 2 as well, so that's correct. Okay, number 10. Or I guess I'll move down and do 16 through 18 at this point as well, because that's what I would do if I were taking it. Okay, I've got 3x. That's going to have to be split over 6x to solve for this middle section here. That's going to give me 1/2. A half times my total height's going to be half times 18. Answer is 9. That's correct. That's checked. 17. Sine of x is 0.6. What's the cosine of y? Also has to be 0.6. That's a law with geometry. What real value of x is the equation above? True. Okay, we go ahead and we group this one. That's going to be x squared. That'll be 2. That's correct. Put our x minus 5s together. Real value is going to have to be 5 then. That one's correct as well. 19. If xy is the solution to the system of equations above, what's the value of x going to be? Okay, this one I went ahead and I multiplied. I saw that this 3 times that 20 is going to be 60. I got to subtract another 60. It's going to be set equal to 0, which means that x will have to equal 0. Okay, that one's correct. That's checked as well. 20. I've got a decrease in total of that negative 75 degrees Celsius that occurs over a change of 30 kilometers, which means every 10 kilometer change would be negative 75 over 3, which would be a negative 25. So our answer there is going to be 25. That's correct as well. I can go back up now, check 10 through 15. Where's 10 at? Got 10 up here. Okay, multiplying each side by t minus 5. I do that. I've got 10t minus 50 equals t plus 5. Subtract t from each side. I get 9t equals 55. Divide each side by 9. That one's checked as well. Number 11. Okay, I've got a system of equations here. How many ordered pairs satisfy it? I set it all equal to 0. When I do that, I see that I'm going to get this right here, b squared minus 4ac. I see that my b squared is going to be positive, and then minus 4 times a times c will be positive since c is negative and a is positive, and I have a minus 4 as well. So that'll give me a positive answer. So that one right there is going to have 2 real solutions. Right here, I've got them paying a 20% tip, so I got that represented by this 1.2 times the price of Paul's, which is X dollars, plus $1, because it's $1 more than the price of Ken's, so I've got 2X then plus 1, splitting it over 2 people. That then is going to give me 0.6 times 2X, which is 1.2X, and then plus 0.6, so that one's correct as well. 13. Okay, I can go ahead and I can take this negative x, 8x plus 2, plug in a 0 here. When I do that, I go ahead and subtract 2 from each side. Negative 2 over negative 8x, that's the same as a 1/4, which the square root of is 1/2. That one's correct. Number 14. All right, so we've got a system of equations here. We got imaginary numbers multiplying by the complex conjugate. When we multiply by the complex conjugate, we're going to get 3 times 3, that's 9. And then we got 9 minus 4i squared, which becomes plus 4, which is going to be 13. Up top, I'm going to have 8 times 3, which is 24. And then a minus I times 2i, that's going to be minus 2i squared, which becomes plus 2. That's going to be 26 over 13, which is 2. That one's correct as well. And now I've got 15. So I've got an equation here. I got to multiply this whole thing by 2, right? And then subtract that 4p once I multiply by 2. When I do that, I end with this equation here. Then I'm using my quadratic formula, and that's going to be over 2a, so it's going to have to be over 4. So C and D are wrong. Next thing I got to check is right here. And when I go ahead and check that, I'm going to have b squared minus 4ac. I know that b is, it's going to be k squared in each one, so I'm just dealing with minus 4ac. I know that c is negative 4. That's going to give me positive 16 times a, which is 2. That's going to give me positive 32. So b is correct there. Okay, so you see at that point I finished with really just about 5 seconds left. So ideally I would have gone just a touch quicker than that, but either way I got to check all my answers. My time is up at this point right now, I think. I believe my time just ended. I'll put some sort of text that shows if it did or not, or you can just check your timer. My timer says it just ended, but I could be wrong. I could have 1 minute left, but either way I didn't end late. If anything, I ended early, but I think I ended on time. So either way, hopefully that was helpful. Hopefully you saw and were able to compare what you did yesterday with what I just did. Hopefully what you did yesterday was similar to what I just did. If you struggled with time, one thing, just kind of pay attention to how I'm solving them, because I'm really using the most efficient way possible in each of these. So hopefully you're able to use that. Hopefully it was helpful. And with that, let's go ahead and switch over to the right. Which one we got today? I'm not sure which one we have today because I'm recording it separately, but we'll go ahead and switch over to the other section now. For today's reading practice, what you'll be doing is you'll be going through a quick refresher for about 3 to 5 minutes on how to pace the SAT reading section, in particular, one passage. And then after that 3 to 5 minute refresher, what you'll be doing is you'll be taking the second passage from SAT Practice Test 4 as a simulated real test-taking scenario. So what that means is that you'll have between 9 to 11 minutes to complete that one passage, and then once that 11 minutes is up, at that point I'll go through that passage in anywhere from 9 to 11 minutes to give you an idea of how to pace that section, or the reading section, as the SAT paced different passages. So try to make sure that you're answering hopefully all 11 of these questions that are in this second passage of SAT Practice Test 4, and right around that 11-minute mark. If you can get it done in 9 minutes, that's even better. As long as you're in that 9-minute to 11-minute range, that's good. If you have to skip 1 or 2 questions or even 3 questions, that's okay. But because if you do take that full 11 minutes to complete it and you skipped 3 questions, keep in mind you're probably going to want to make sure that you're getting that done in a little bit faster of a time, just because if you are skipping 3 questions, you're going to want to be more on that 9-minute end. But if you're not skipping any questions, then being on that 11-minute end will be okay, if that makes sense. Because if you're taking that 11 minutes, you're skipping 3 of them for each passage, then you're going to have to come back and do 15 of them with only 10 minutes left, and that's really bad pacing. So if you're going to skip 3 of them, try to finish in 9 minutes. If you're not skipping any, finish in 11 minutes. So that's why there's kind of that range. So with that, let's just go through a quick refresher of how to pace these passages. So we have reading the passage. So when we read the passage, we don't want to skip lines. We don't want to try to predict anything, and we want to keep in mind our feelings don't matter. Keep in mind we don't want to reread on our first read-through of the SAT reading section or an SAT reading passage. So we don't want to reread anything. We also don't want to write a lot of notes down. We want to keep on moving, so keep on reading. Always keep reading when you're doing that first read-through. We want to stay interested because it'll help us remember things. So like I said, limiting the number of annotations that we're making, trying to finish our initial read-through in anywhere from 3 to 3.5 minutes would be ideal. So 3 to 3.5 minutes, that's ideal. If it takes you 4 minutes, that's okay, but keep in mind we always want to make sure we're staying under that 4-minute mark. Now we want to aim to answer all of our questions on any of the sort of section, so say that it was questions 1 through 10 or questions 11 through 21, we always want to make sure that we're answering all of those questions or as many as we can without skipping more than 3 in anywhere from 9 minutes to 11 minutes. So if you're skipping 3, you want to do that in right around 9 minutes. If you're not skipping any, doing it in anywhere from that 9 to 11 minutes is perfectly fine. So what this is going to do is it's going to leave us with 10 to 20 minutes at the end to check our work, check any questions we skipped or were unsure of, which will really help us make sure that we're being as efficient as possible. Now, we want to do the passages obviously in the order that they're easiest to you. Keep in mind today you're only going to be doing one passage, so you're not going to be able to apply that concept today. But overall, I think that kind of gives you a good idea of what you'll be doing. The other thing is skip a question. If you feel very unsure of it after 30 seconds, make sure you star skip questions so you know where they are in your test booklet. Obviously today you're not going to be having a full test booklet, but still understanding that as a concept. Trying not to skip more than 3 questions per passage. If you're skipping more than 3 questions per passage, that's just going to put you in a bad spot, because then you're going to have to go back and you're just going to have to answer too many, and you'll have ideas coming from different passages, and it's just not a good idea to skip more than 3 questions per passage in my opinion. As I've stated before, we want to make sure that we are reading through the whole text before we start answering the questions, because otherwise we're not going to understand the big picture of the text. So that's something that you should already know. Hopefully you do, because I talked about it in the pacing video a couple days ago. And with that, we can go ahead and switch over now, and you'll be given that 11 minutes to complete this practice SAT. So it's SAT Practice Test 4. You can find that one if you just Google SAT Practice Test 4. It'll come up as a PDF. Click on the PDF. You'll be able to find the reading section. Today it'll be questions 11 through 21. So that's going to be the second passage of that reading section. So I will give you 11 minutes on your screen to complete it. At the end of that 11 minutes, I will say your time is up. Keep in mind that if you finish in 9 minutes, that's even better. Obviously, we want to finish in that 9 to 11 minute range. I'm allowing that 11 minutes just for pacing reasons, obviously. But if you can finish in 9 minutes, that's even better. So keep that in mind. And with that, it's going to get started here in right around 5 seconds. So I'll count you down. Make sure that you pull up that PDF. And with that, you are going to start in 5, 4, 3, 2, 1. Your time is now finished for that 11 minutes to complete that second passage of SAT Practice Test 4. Hopefully you were able to implement some of those pacing strategies that I gave you. Hopefully you were able to get through that full passage and all of its questions in 11 minutes if you didn't skip any. If you were skipping some, hopefully you only skipped at most 3 questions. If you did skip 3 questions, hopefully you were more on that 9-minute side as far as finishing with 9 minutes left if you did skip those 3. And hopefully you did go back, obviously, since you had 2 minutes left, or it's fine if you paused. Either way, what we're going to get into now is the answer explanation. So you're going to be able to check your work, see what you got right, what you got wrong. Also, you'll be able to compare how you pace versus how I do, because I'll be completing this in under 11 minutes as well. So I won't be skipping any, obviously, since I'm giving you the answer explanations. So I'll be completing this in less than 11 minutes, probably anywhere from 9 to 10, but it could take up to 11. Obviously, that's the range that we're shooting for. So as I go through this, what you want to pay attention to is a few things. Obviously, the first thing that you're going to pay attention to is what am I underlining or highlighting as I go through this. The next thing you're going to want to pay attention to is how I'm answering these questions. How am I getting rid of wrong answer choices? How am I getting to the correct answer choices? How am I doing this efficiently, right? Try to pay attention to any sort of strategies I use to get rid of answer choices quickly. Try to pay attention to how I'm pacing. So that's one thing you want to look for. The other thing that you're going to want to pay attention to, I guess really that's honestly probably about it. There's not really much else I would add on to watch for other than just making sure that you're paying attention to compare how you got to your answers versus how I did. Obviously, check if your answers are right, and then obviously just look at my pacing. So with that, I'm going to go ahead and get started here in about 3, 2, 1. Questions 11 through 21 are based on the following passage and supplementary material. This passage is adopted from Allen N. Halt, The Great Inversion and the Future of the American City, copyright 2013 by Vintage. Aaron Hart is an urbanologist, a scholar of cities and their development. Demographic inversion is a phenomenon that describes the rearrangement of living patterns throughout a metropolitan area. We are not witnessing the abandonment of the suburbs or a movement of millions of people back to the city. The 2010 census certainly did not turn up evidence of middle-class stampede in the nation's cities. The news was mixed. Some of the larger cities on the East Coast tended to gain population, albeit in small increments. Those in the Midwest, including Chicago, tended to lose substantial numbers. The cities that showed gains in overall population during the entire decade tended to be in the South and Southwest, but when it comes to measuring demographic inversion, raw census numbers are an ineffective but blunt instrument. A closer look at the results shows that the most powerful demographic events of the past decade were the movement of African Americans out of central cities, 180,000 of them in Chicago alone, and the settlement of immigrant groups in the suburbs, often ones many miles distant from downtown. Central city areas that gained affluent residents in the first part of the decade maintained that population in the recession years from 2007 to 2009. They also, according to a 2011 study by Brookings, suffered considerably less from increased unemployment than the suburbs did. Not many young professionals moved to new downtown condos in the recession years because few such residences were being built, but there is no reason to believe that the demographic trends prevailing prior to construction bust will not resume once that bust is over. It is important to remember that demographic inversion is not a proxy for population growth. It can occur in cities that are growing, those whose numbers are flat, and those who are undergoing a modest decline in size. America's major cities face enormous fiscal problems, many of them the result of public pension obligations they incurred in the more prosperous years of the past 2 decades. Some, Chicago, prominent among them, simply are not producing enough revenue to support the level of public services to which most of the citizens have grown to feel entitled. How the cities are going to solve this problem, I do not know. What I do know is that if the fiscal crisis were going to drive affluent professionals out of central cities, it would have done so by now. There is no evidence that it has. The truth is that we are living at a moment at which the massive outward migration of the affluent that characterized the second half of the 20th century is coming to an end, and we need to adjust our perceptions of cities, suburbs, and urban mobility as a result. Much of our perspective on the process of metropolitan settlement dates, whether we realize it or not, from a paper written in 1925 by the University of Chicago sociologist Ernest W. Burgess. It was Burgess who defined the 4 urban, suburban zones of development: a central business district, an area of manufacturing just beyond it, then a residential area inhabited by the industrial and immigrant working class, and finally an outer enclave of single-family dwellings. Burgess was right about the urban America of 1925. He was right about the urban America of 1974. Virtually every city in the country had a downtown where the commercial life of the metropolis was conducted. It had a factory just beyond it. It had districts of working class residences just beyond that, and it had residential suburbs for the wealthy and upper class at the far end of the continuum. As a family moved up the economic ladder, it also moved outward from crowding working class districts to more spacious apartments and eventually to a suburban home. The suburbs of Burgess's time bore little resemblance to those at the end of the 20th century, but the theory still essentially worked. People moved ahead in life by moving farther out. But in the past decade, in quite a few places, this model has ceased to describe reality. There are still downtown business districts, but there are no factory districts lying next to them. There are scarcely any factories at all. These close-in parts of the city, whose few residents Burgess described as dwelling in submerged regions of poverty, degradation, and disease, are increasingly the preserve of the affluent who work in the commercial core, and just as crucially, newcomers to America are not settling on the inside and accumulating resources to move out. They are living in the suburbs from day one. All right, and then we've got, looks like a chart, and then a second chart as well. Now we can go ahead and get into our questions. So we have which choice best summarizes the first paragraph of the passage? Okay, well, we know that our first paragraph is really talking all about population growth and demographic inversion, but they make a specific claim about that. Okay, if we go back to paragraph 1, we see that our claim about demographic inversion is that, as opposed to population growth, is that those two are separate ideas, right? It's important to remember, we say that in this highlighted section here, it's important to remember demographic inversion is not a proxy for population growth or is not the same as that. And that's really what we describe throughout all of this, is we're describing demographic inversion, and then we're also saying it's not the same as population growth. So we're kind of making that distinction between those two. That's really what we focus on throughout that paragraph. So let's run through options A through D. We have A, the 2010 census demonstrated sizable growth in the number of middle-class families moving into inner cities. That's not summarizing our first paragraph. B, the 2010 census is not a reliable instrument for measuring population trends in American cities. Also not a summary of our first paragraph. C, population growth and demographic inversion are distinct phenomena. Yes, that's showing that they're separate, and demographic inversion is evident in many American cities. We also make that claim as well. So that is a good summary because we're making both of the claims that really summarize that first paragraph. 12. According to the passage, many members of which group moved away from the central city areas in large numbers in the early 2000s? Okay, we talk about this when we say the decade before. I'll go ahead and show you guys where that is. That's when we talk about how, I believe I highlighted it as well. Okay, right here, we talk about the past decade, which we know since this is copyrighted in 2013, that's going to be 2000 to 2010, the movement of African Americans out of central cities. Okay, so it's going to be that group right there. We go down, find it. We see that we have option D then for number 12. Okay, question 13. In line 34, flat is closest in meaning to what? Well, let's go to line 34 and come up with our own answer. We have in cities that are growing, those whose numbers are flat. Okay, that would indicate that they're unchanging. So I'd look for something that says unchanging or static, anything that indicates that there is no change. So unchanging, we see we do not have that, but we do have static, which means unchanging as well. So our answer there would be A for number 13. Okay, number 14, let's take a look at what that is. According to the passage, which choice best describes the current financial situation in many major American cities? Okay, we know that we talk about how there's economic hardship due to promises made in the past. Okay, so where do we talk about that? Well, I'm guessing our next question is evidence, which it probably is. I see it is, so I'll go ahead and find that as well. That's going to be where we talk about, let me see where we've got it. We talk about how there has been a, right here, okay, starting in 36. I'm going to go ahead and circle it. Okay, so it's 36, it looks like, to right around 39. We talk about America's major cities facing normal fiscal problems, many of them the result of public pension obligations they incurred in more previous decades. So that's going to be 36 to 39 would be my best evidence for that. Okay, so my answer there is going to be A for number 15. All right, so now we've got question 16. So we've got the passage implies American cities in 1974 what? All right, American cities in 1974. Okay, we know that we talk about at the end right here. Okay, we talk about American, where is it at? Right here, down at the bottom of 65. I'm circling it in blue. We talk about how he was right about the urban America of 1974 and the fact that it had 4 zones of settlement. Okay, so we're talking about there's 4 zones of settlement according to Burgess and that he was right in 1974. So we want to say something about there being 4 zones of settlement. So we see that we have option C had a traditional 4-zone structure. So that would be our correct answer there. I'm guessing we have, it looks like we do have evidence for our next one. So our evidence for our next one, I would look for where we talk about that 4-zone structure in 1974. I see that we talk about it after this sentence right here that I'm underlining in blue. So we talk about virtually every city in the country. Okay, so obviously we're talking about at that time, virtually every city in the country. We have whether the commercial life was conducted, it had a factory, it had districts of working class residences, and it had residential suburbs. So that's kind of showing our 4 areas there. So it looks like that was lines up to 70 or 71 from 66. 66 or 65 to 71. Okay, I got 66 to 71, so my answer for 17 then would be C. All right, moving down, we got question 18 now. As used in line 68, conducted is closest in meaning to what? Well, let's go take a look at conducted in the context of the problem. It said it was in 68. So we got to go up top here. We have the top then of our right side. We have it had a factory just beyond. It had districts of working class residents. Oh, I'm sorry. It's right here. I'm going to put it in green so you can see it better. Okay, I'll circle it. So we have where the commercial life of the metropolis was conducted. Okay, commercial life of the metropolis, where it was conducted. That would mean where that commercial life is carried out, where that commercial life is executed. Executed would be not really a great word choice. Carried out would really be the best if we have that as an answer. We see that we do, so our answer then for 18 would be A. Okay, now we got question 19. We have the author of the passage would most likely consider the information in chart 1 to be what? Well, what is the information in chart 1 showing? Okay, it's showing my 2010 population shares by metro size. Keep in mind, my whole passage was really about population growth and also changes in population demographics, right? Demographic inversion. So us just getting 1 year isn't going to show us any change. So it's really not going to be that useful to this guy in his passage. So I'm going to look for something that kind of talks about that. That might be right here. That's going to be B, possibly accurate. He's not going to argue it might be accurate, might not. He doesn't really care. But he's saying it's not truly informative because he can't make any conclusions on it because there's nothing to compare it to. He wants something to compare to. So the answer for 19 would be B. He doesn't really care what it is. He wants to be able to show changes over time, that demographic inversion. 20, according to chart 2, the years 2000 to 2010 were characterized by what? Well, let's go take a look. Okay, 2000 to 2010, I see that that's my white box. So I see if I look from 1990 to 2000, which is the gray box, I see declines in all 4 of these. So I'm going to look for something that shows a decline in growth rates for all the areas in that period. So I'm going to go down, see what we got there. So you're looking for more growth. I'm not looking for that. I'm not looking for roughly equal growth. I'm looking for a decline in growth. So we have option A, less growth in metropolitan areas of all sizes had taken place in the 1990s. Yes, that's correct. It's showing that drop that we had in that growth rate. So our answer there is going to be A. All right, 20. Chart 2 suggests which of the following about population changes in the 1990s. Okay, population changes in the 1990s. We got to go back up and take a look at our graph. Okay, population changes in the 1990s. Keep in mind, a change from the 1990s would have to come. We have to compare it then to our 1980 to 1990. So I'll put that in blue. I see I have an increase here as well, and an increase in non-metro. So I have an increase in all of my areas from 1980 to so from basically 1980 to 1990, that decade, to that 1990 to 2000 decade. So I see the 1990s then were characterized by growth across all of them. Okay, I'm going to look for an option that shows that they all grow. I see I have the U.S. population as a whole grew more in the 90s than in the 80s. That is true. We had a higher growth rate in all of those, so our answer there would be D for 21.